Welcome to this video on frame analysis, and specifically we will focus on simple and complex pins in frames in this video. You may also like to look at this textbook for many solved examples, and you may consider this software which will help you solve engineering statics problems. Simple and complex pins in frames and machines. In this video, we will mainly focus on the identification of simple and complex pins. Classifying pins into two groups, simple and complex, is not a standard procedure. And your professor in your engineering statics class may never tell you about simple and complex pins. First, you must learn to identify complex pins and then learn how to analyze them. Unfortunately, most textbooks do not even have any exercise or example problems with complex pins. But you must know how to analyze complex pins because you will see plenty of them in real life. So this is the first example. It's a frame, and here we have a multi-force member, a two-force member, a pin support, and a pin support. At this pin support, we have only two interactions, the wall and the member. At this pin, we have only two interactions, wall and the member. However, this pin is slightly different because we have more than two interactions. There are two members and a force. So three interactions. When you have more than two interactions, we classify that as a complex pin. Two interactions, simple. Two interactions, simple. Three interactions, complex. Next problem. Two interactions, wall and member, simple. Two interactions, wall and member, simple. Three interactions, two members and a force, complex pin. Two members and a force, complex pin. Three members, three interactions, complex pin. Two members and a wall, complex pin. Two members and a wall, complex pin. Two members and a force, complex pin. Wall and a member, simple pin. Wall and member, simple pin. Two members, simple pin. Two members and a force, complex pin. Two members and a force, complex pin. Wall and member, simple pin. Two members, simple pin. Three members and a wall, four interactions, complex pin. Three members, complex pin. Two members and a force, three interactions, complex pin. Wall and member, two interactions, simple pin. Two members, simple pin. Two members and a force, three interactions, complex pin. Two members and a force, three interactions, complex pin. Two members and a wall, complex pin. Pulley and a member, two interactions, simple pin. Two members, two interactions, simple pin. Wall and member, simple pin. Pulley and member, simple pin. Two members, simple pin. Two members, simple pin. A member, a rope, and wall, three interactions, complex pin. Wall and member, simple pin. Two members, simple pin. Two members, simple pin. Wall and member, simple pin. Two members, member 1, member 2, and the piston. Three interactions at this pin, so it's a complex pin. Analysis. So what is the definition of a simple pin? Two interactions. A simple pin transfers force according to Newton's third law. Action equals opposite reaction. And we need not draw free body diagram of simple pins. At a complex pin, there are three or more interactions. You have to draw a free body diagram of complex pins. So bottom line is this. Simple pin need not draw free body diagram. Just apply the third law. Complex pin, three or more interactions, you must draw the free body diagram of the pin. Thank you for watching.